So the topic is based largely on temperatures. Hello, can you hear me?
Yes, sir.
It's based largely on temperatures. And this is physics 101. The topic is elementary mechanics and heat and the properties of matter. So we are going to see some of the course outline. So here we are. The for the one, say concept of temperature, types of temperature, measurement of heat, thermal expansions, then gas law. So model one contained 5 units, 5 units, and each of the units are very broad. Model two contain molar heat capacity of gases and the conduction of heat. Then the mode two also, we have conventional radiation. Those are mode of heat or transferring heat. The molecular properties of materials. Mode three, we have elasticity of matter, moduli of elasticity, kinetic theory, and buoyancy and Archimedes. Then mode four, which is last, pressure, elements of hydrodynamics, viscosity, surface tension, and other properties of gases. So this is what we have. So we're going to take these things step by step. And one thing I always stress in my classes, always ask questions whenever you don't understand. It's part of our learning process. So it's very key to our learning. There is here we go with temperatures and the rest. So concept of temperature. So this is
Mm.
what yes, this is the first concept of temperatures. I hope you can see my screen.
Yes, sir.
Okay. So let's understand what temperature is. Let us understand what temperature is. Whether we are outside, we are inside, we feel some level of heat, right?
Yes.
Uh-huh. Heat itself eh, is a form of temperature. It's temperature that gives us a heat. So when you are
Mm-hmm.
feeling heat, it's as a result of temperature. If you are feeling cold, it's a result of temperature. So
Temperature.
temperature is responsible for hotness or coldness of any environment, of anywhere you find yourself. Okay,
Mm-hmm.
there's always temperature. At all points, there's always a temperature. In your refrigerator, there's temperature. When your fridge is cold, it's cooling at a certain temperature. Where your things are cold, it's cooling at a certain temperature. When you put hand in water, is that water is at a certain temperature. If you use a measuring instrument to measure it, it's going to give you a certain value. Okay,
Yes,
so
sir.
everything about this is temperature. So when people say I'm feeling heat, it's not heat per se, it's temperature. The temperature of the day or of that weather is hot, which generates heat. Okay,
Yes, sir.
so what we're going to do now,
Okay.
we're going to define temperature. We're going to define temperature and understand the science of temperature and how do we identify temperature. So we're going to take it gradually. Like I said, all ask questions if you don't
Mm.
understand. Yes, very important for our learning. So generally, there are ways people define temperature. There are ways people define temperatures. Right from secondary school or primary school, we are told that temperature is the degree of hotness, of coldness of a body, right?
Yes.
Mhm. That definition has not changed. Although, when you come to advance like this 100 level now, they define it in a different form. Although it does not invalidate the definition of temperature is degree of hotness or coldness of a body. It does not invalidate it. So we're going to take the definition, and state the units and other things that follows. Please, like I said, ask questions if you don't understand what we are doing.
No problem, sir.
Yes. Okay.
So this is just the first part of
For the course,
this.
the course.
Yes.
Mhm. All right. So let's start with definition of temperatures. Okay. So I will dictate it. You do the writing.
All right, sir.
Yes. So temperature is let's start with the basis. Temperature is a fundamental quantity. Meaning, let me explain to you what I mean by fundamental quantity. So it does not depend on us whether the weather should be hot or cold. Does it depend on us?
No, it depends on
Uh-huh.
the weather, temperature.
It's in Yeah, it's a natural phenomenon. It's something natural. So those things that
Mm.
occur naturally, they call them fundamental quantities. Uh-huh. So that's why I said temperature is a fundamental quantity because it occurs naturally. It does not depend on you and I to happen. So those things does not
Mm.
depend on you and I to happen. We call them or classify them as fundamental quantities.
It's okay.
Okay. Yes, like for instance now, it does not depend on us. It does not depend on us how heavy a material should be, as in how heavy a stone should be. It does not depend on us how heavy a rock should be. Does it depend on us? No.
No, sir.
And those that do not depend on us before they happen naturally. We call them fundamental quantities. That's why I said temperature is a fundamental quantity. Why? It does not depend on you and I to take to happen.
Mm.
Yes. So right, right. That temperature is a fundamental quantity.
Okay.
Mm.
Done.
Okay. Are you done with that?
Yes.
Okay. So you understand what I meant by fundamental quantity, right?
Yes, sir.
Uh-huh. So temperature is a fundamental quantity. So and it is defined as the degree of hotness or coldness of a body. And it's defined as the degree of hotness or coldness of a body.
Hotness
Or
of
coldness of a body.
of the body. Of a
Of a,
body or
yes, of a body.
okay.
Yes.
Done.
Okay.
Hear my answer.
Are you there?
Yes, sir.
So that is the primary definition of temperature. But when you come to advanced level, temperature has a different definition. Okay.
Mm.
It
Yes,
has
sir.
a different definition. So, right, paragraph temperature is also defined. Temperature is also defined. Temperature is also defined. Are you there?
Yes, sir.
As the average kinetic energy. As the average kinetic energy.
As the
Average kinetic energy.
help me with the kinetic. Okay, K
Kinetic.
I.
Average kinetic energy.
Done.
Okay. Of the particle, of the particles of a substance, of the particles of a substance, of the particles of a substance.
It's also defined as an as
No,
average
I know
kinetic
kinetic energy of the particle of a substance,
of the particle
particles of a substance, of the particles of a substance.
substance.
Yes.
Done.
Okay. So, right, paragraph. Temperature is paragraph.
Yeah.
Temperature is measured, right? Temperature is measured with an instrument called thermometer. Temperature is measured with
Measure
it's measured. It's measured.
which
It's
and
measured with an instrument called a thermometer. It's an instrument called a thermometer.
thermometer.
Yes. So have you? I don't know if you have seen or used a thermometer before.
I think so, yeah.
uh Although there are
Yes,
different
yeah.
types of there are different types of thermometers. There are different types. The most common one we see are those one we see around the clinic, pharmacies, and the hospital.
Hospital, yeah.
And yeah, those are the common one we see. But if you take a look at it very well, you are going to see if you turn the thermometer, you see something like liquid inside.
Yes. Yes.
uh So with that thing inside the thermometer look like liquid, we call them thermometric. They refer to them as thermometric substance. That's what they call them, thermometric substance. That
So
thing
should I
can
write
be,
it down?
no, I'm just explaining. We are going to do that later. So that thing you are seeing inside that thermometer look like liquid. We call them thermometric substance. That thermometric substance can be alcohol, can be mercury, it can be any thermometric, anything that varies with temperature. That's what we use to construct thermometers. Do you understand? Anything that varies with temperature, that's what we use to construct thermometers.
Yeah.
So, right, paragraph. The thermometer use any physical property of a substance.
Hold on, sir. Come again.
Thermometer use thermometer use
Used or
yes
use?
used the
Uh-huh.
thermometer use any physical property, any physical property
Mm-hmm.
that varies or which varies with temperatures, temperatures.
That varies
With temperatures.
temperature.
Yes.
Done.
Okay. So let's understand what we mean by thermometric substance. Right? That thermometric substance. Okay. Are you seeing my board?
Yes, sir.
Okay, let me just write the definition. So thermometric substance are substance as substances or substance whose physical property, whose physical property, whose physical properties are used in the construction, in the construction of thermometers, in the construction of thermometers.
Done.
Okay, so let's get example of thermometric substances. Let's get the example. So what I mean by I've described it to you. That liquid thing you
Yes,
see is a
it might
hand.
be liquid. It can be
Yeah,
alcohol,
yes,
water, or any
that
substance, as long as it's a
that
liquid substance.
that varies with temperature, and those are thermometric substance. So let's get some of the examples of thermometric substance.
Substances.
Yes, or substances. Yes. Let's see. The first one is liquid in glass, or let me say alcohol. Let's say alcohol. Of alcohol is a thermometric substance. Okay. The first one is alcohol. Alcohol is example of a thermometric substance, or also known as ethanol. If you want to do chemistry, you see the word instead of calling it alcohol, some people refer to it as ethanol. Then
Ethanol.
yes, number two substance is mercury. In fact, the one you see in the hospital, that liquid substance is actually mercury. It's mercury.
What is it? Mercury.
The one we use in around our clinics, hospitals, and pharmacies. The mercury substance inside is mercury.
Okay.
Yes, it's mercury. Yes. Then number three, another example of a thermometric substance, we have platinum wire. Platinum, platinum wire is also an example of a thermometric substance. Then number four, we have gases. Gases like hydrogen or helium. Hydrogen or helium is an example of thermometric substance. Okay. Then we have another
Um,
one, which is number five. We have dissimilar wire. Dissimilar dissimilar mentals, such as copper and constantant, copper and constantant, and constantant. Okay, number six, we have a bimetallic.
if I may ask, what are the similar metals?
Okay, the dissimilar metals is used in a type of thermometer. We're going to come to that later. We call it
Okay.
thermocouple. We call it thermocouple. We'll come to it later. Yes, these are just we are
Okay.
just mentioning the examples of thermometric substance, and we use
Okay.
the one we see every day is the one they use in hospital. We call that that thermometer we use in hospital. The thermometric substance inside is mercury, but all these ones are some of the things we have not seen physically. But they are
Okay.
thermometers, yes, but I've not seen them. So that's why I use that. So that dissimilar wire, we call it thermocouple. It's used to measure very high temperatures. It's used to measure very high temperature beyond what that thermometer can measure. It used to measure very high temperature.
Beyond what thermometer can measure.
That one we use in hospital, it has a certain
Mm,
range. Thermometer has certain range.
okay.
But
Yeah. Yeah.
the range of the dissimilar wire is very high. It used to measure very high temperatures.
Okay.
Yes. Then the last one, we call it bimetallic. Bimetallic strip. So these are the types of thermometric substance that we have. There are a few types of thermometric substance that we have.
Okay.
Yes.
Alcohol, mercury, platinum wire, gases, hydrogen, and helium, dissimilar metals,
Mm.
and bimetallic. Please, sir, pronounce the last one again.
Bimetallic.
Bimetallic.
Bimetallic strip. Bimetallic, so because it's bimetallic. Now bimetallic strip.
And bimetallic
Bimetallic
strip.
strip, yes.
Okay, sir.
Yes. So these are the thermometric substance. So when I say thermometric substance, you understand what I meant, right?
Yes, sir.
Those substances' physical property varies with temperatures. We call them thermometric substance. So let's see types of thermometer now. Types of thermometer. Types of thermometers. Types of thermometers. So let's look at types of thermometers. Okay. Hello.
Yeah, I'm here, sir.
Okay. So we're looking at types of thermometer. The first one we have, which is very common one, we call it liquid in glass. Liquid in glass thermometer. Liquid in glass thermometer. This is the first thermometer we have. We call it liquid in glass thermometer. Okay.
Yeah.
So that thermometer you say you have seen, that thing inside is the liquid, Abi.
Yes, sir.
That's all that kind of thermometer we call it liquid in glass because there's liquid inside the glass that make up the thermometer. That's why they refer to it as liquid in glass thermometer.
Yes, like such as mercury, alcohol.
Exactly, exactly. So the thermometric substance, right? The thermometric substance is alcohol, alcohol or mercury, alcohol or mercury. Okay. That's the thermometric
Yeah.
substance inside it. Now, what's the physical property? Physical property means what you can see. So, what are the physical properties of liquid in glass, right? Include physical properties. We have it changes or change in volume, change in volume of liquid with temperature. Change of volume of liquid with temperature. Now, if you have used it, before they put the thermometer on the armpit or the tongue of the patient, he has to say the liquid will be at a certain level, right? So
Mm,
when they put it on the patient
yes,
and
sir.
remove it, what will happen to the liquid? what will happen to the liquid? It will goes up.
It will shift. It
Yes,
will
we
shift
go.
from the first direction to another
Yes,
different
to
direction.
that point, the volume always increase. It change the volume always change as a result of the
Okay.
temperature involved. So
Okay.
that's one thing we can see. That's what we refer to
Yes.
it. This you can see. We call them physical properties. So the change in volume of liquid with temperature. As temperature increases, the volume of the liquid also increases.
Increase it.
Yes. That's why
That
that's
is
why that's why you not see the doctor or the nurse telling the patient that your temperature is very high or your temperature is normal. So
uh-huh.
it changes with temperature based on so as temperature increases, the also it also
Increase.
increases. Yes. So the second type of temperature we have of thermometer we have second type we have number two we have gas thermometer. Gas thermometer. That's number two. So what would be the thermometric property? The thermometric property is autometric substance, thermometric substance is gas. The thermometric substance of a gas thermometer, what is inside is gas.
So how can it be defined now, sir?
Okay. Uh, it changes, the gas pressure changes with temperature. Gas pressure changes with temperature.
Okay.
As the pressure of the gas is increasing, the temperature is also increasing. Yes, so all you have to do physical property, physical property, gas or pressure. Let me say pressure changes, pressure changes with temperature. Pressure changes with temperature.
Okay.
Yes.
Okay.
So pressure changes with temperature. So as the temperature, the pressure is increasing. If either of them is increasing, or so that is why I don't. If you have been to a gas station,
Yes.
periodically they cool the cylinder, they cool the cylinder where the gas is.
Where the one that generates the gas or that supplies
Yes,
the
some people normally freeze water on top to cool it.
water tank that will be cooling
Yes,
it.
to cool it. Yes, that's what they mean by it. That's what they're trying to tell me. Why are they cooling it? Because at the during the afternoon, when the temperature heats or when the sun heats the cylinder container, the molecules of the gas inside will begin to increase. So if the design of the cylinder is poor or you didn't cool it, it might explode.
Yes.
So that's why they cool it. Why? The pressures of the molecule inside the gas begin to increase. So as temperature increases, the pressure also increases.
Increases.
Yes, and that's gas thermometer now. Is used to measure gas. Okay, it's used to measure gas temperature. Is it understood?
Yes.
Okay. Let's go to number three. Go to number three. We have number three should be resistance thermometer. Resistance thermometer.
Resistance, right?
Yes, resistance. Yes, resistance thermometer. So thermometric thermometric substance is. is resistance wire. Is resistance wire. Thermometric substance is resistance wire. Okay.
Okay.
Yes. So I don't know. Yeah, if some wire, if you plug some, let me use our phones. If you plug phone for a long time, what happens if you touch the charger head or the wire?
Okay, it gets hot. The temperature increases.
Exactly. That's what they mean. That's what they mean here. So the instrument to measure that temperature of the wire is what we call the resistance thermometer. Is used to measure the resistance, the temperature of a hot electrical substance. Uh-huh. So the thermometric substance is resistance wire. Then the physical property is that electrical resistance changes with temperature. Electrical resistance changes with temperature. Electrical resistance changes with temperature.
Changes.
With temperature. Mm.
Okay.
Mhm. So these are practical things we are using to describe the examples now. Then are you done with this one?
Yes, sir.
Okay, let's look at number 4. Number 4 is what we call thermocouple. Remember I mentioned at that time two
Yes,
dissimilar
and I asked you. Question.
yes, two dissimilar wires. That's what we said about it. Thermocouple. Yes. Thermocouple operates with two dissimilar thermometric substance now. Sorry. The thermometric substance, thermometric, thermometric substance is two dissimilar wires. Two dissimilar wires. Okay. Then the physical property change in electric potential difference, electric potential difference between two wire junctions, between two wire junctions at different temperature, at different temperature.
The physical properties changes in electric
Yes,
potential
electric potential,
difference
yes.
between two
Two
wire
junctions,
junction.
two wire junctions,
Okay,
yes. Two wire
at
junction,
at different temperature.
yeah, different temperatures, yes.
What's the heat meter?
Are you done with it?
Yes, sir.
Okay. So this thermocouple is a unique types of thermometer. So what I would do, they might ask you, they might draw the diagram for you, and they might ask you to detect to label some part from it. So what I would do, I would draw the diagram of the thermocouple. Okay. So you can, where you see it, you should be able to identify it. So diagram of thermocouple. Diagram of a thermocouple.
Yeah.
Are you there?
Yes, sir.
Okay. So it's something like this. It has there's a potential difference, which is V. What we say potential difference is the V. So we have two junctions. Here is one junction, here is another junction. So let me erase this part so I can complete the diagram. Then we have one wire here like this. This junction, you call it the hot junction, while the other one is cold. We have a wire from here to here, and we have another wire from here to here. Okay, so this is mental B. Let's call this mental B. Then this is mental A. Then this is hot junction. The first one is hot junction. The second one is cold junction. So this your V is your potential difference. Potential difference. Please just make the sketch. This is diagram of a thermocouple, like we said earlier.
Okay.
Mm.
You said the left side is called
Junction. The right, no,
hot.
the left side. From where I'm sitting now, I'm at the left. The left is at the hot junction. I don't know how you are saying it there. Then
The hot junction.
yeah, the right side of me, where I'm sitting, is the cold junction.
Right.
Mm.
Cold junction.
Yes.
So what the diagram defines the thermocouple.
Couple, yes. Diagram of a thermocouple, yes.
Okay.
Yes.
So the V represents the potential
That difference, yes. Potential
difference,
difference. Mm.
meaning is the one that connects to the
Yes,
wire,
both the
right?
hot, yeah, both the hot and the cold junction, yes. It's like the potential difference is like your battery. It's like a battery. When you plug a battery and two wires are connected to the
Okay.
battery, the potential difference, like a
Can
typical
use a
example,
powerhouse.
Please,
Okay.
yes, is one
please,
that
can
supply
you
is one that supply the current or the electrons to both junctions. Yes.
sir, please, can you come back from the,
Okay.
from the beginning, please? I'm lost.
Well, it is thermocouple.
Yes, from the explanation of the diagram.
Okay. Okay. Um, the the thermocouple, like we said, is an instrument we also use to measure temperatures, right? Thermocouple has two junctions. Who are the two junctions? We have hot and cold junction. Why are we having hot and cold junction? Because it contains two dissimilar wire. The wire are not the same. Okay, so one of them will react with, or one of them will react with the current. The other one will not. So the one that react with the current is the one that will produce the hot junction. The one that does not react with the current, the one that produces the cold junction. So these two wires, that's why it's labeled mental A and mental B. Both of them are two dissimilar mentals or wires.
Uh,
You understand?
Excuse me, sir. Can we kindly say is negative and positive if I'm to ask?
No, no, you can't classify them as positive and negative.
Okay.
They react based on the amount of electrons or current they receive.
Okay.
Yes, the one that receive more, they have the tendency to be hot. The one that receive less have the tendency to be cold. Okay.
Okay, sir.
Yes, that's an instrument to measure temperature also. So these are some of the basic types of, and then lastly, I don't know if you have done read the diagram.
Yes, sir.
Yes.
Okay. Lastly, we have a bimetallic thermometer. Bimetallic. Bimetallic thermometer.
Bimetallic thermometer.
Thermometer. Yes. So this kind of thermometer is that's what you find. That's what you find in your electric iron.
Okay.
Yes, if you go to electric iron, when you plug it, eh, it becomes after some time, say the red light will off. It will try to be
Yeah.
cool, and when you get to a certain level, the temperature will be when you attain a certain temperature, it will switch. The thermostat that regulates it. Thermostat will switch because the temperature is becoming too high. So a bimetallic thermometer is found in your is what you use to design your electric iron. So what does it contain? If you open the electric iron, you're going to see two metals inside. It's like they want to touch each other. But so it's only when they touch, it becomes hot. It will not generate heat. So when they detach, that is when the wire. That's why that is when that red light off because of it has expanded to a certain level. Both of them will detach. Okay. So this one contains the thermometric substance, thermometric. Thermometric substance is two dissimilar mentals. Two dissimilar mentals. That's the thermometric substance. It make up of a bimetallic thermometer. There's the physical property of it. Physical property. Different expansion. Different expansion. Just as I just explained. Different expansion of the bimetallic strip. Bimetallic strip. Okay, so these are the types of thermometer that we have.
So you say the physical properties. Please, can you explain?
Different expansion of the bimetallic strips. Like I told you, inside your electric iron, you see two men. If you can open it, you see two metals that are almost touching each other. So when you plug the electric iron into your power source or the socket, you see the red light will click, we pick up, right?
Yes.
When red light pick up, it means that the the electron or the voltage that's entering the wire is heating up that mental. That is why
Yes.
that is why the light is up. Then when it gets to a certain level, as it's getting hot, it will transfer that heat. It will transfer that heat to the other mental.
Okay.
Yeah. When it transfers the heat to the other mental, and when that mental is getting hot to a certain level, both of them will separate. When they separate, that is when that red light will off. Then
Okay.
when you heat again, the red light will pick up. Then it's a continuous process. It does not stop.
Okay.
In as much electrons are flowing into the system or current is flowing inside the system, it does not stop. That's why you see the red light will off and on because of the expansion that is taking place inside.
in the temperature.
The different expansion of the
Of
bimetallic
the
strips.
yeah, of the two mentals inside. Of the two mentals
Yes.
inside. Yes. That's what they call it bimetallic. Bimetallic means two. The word bi. Some people play it as
Bimetallic.
bimetallic. Bimetallic. Some people call it bimetallic. So bi means two. Means two mentals that are mental, two metallic mentals. I hope it's clear.
Yes,
Yes.
sir.
So where we are going to now is very interesting, and I want you guys to pay very good attention to this part. We call it temperature scale. Temperature. Okay, let me say.
Can you go with the examples of the thermometers?
Yes. Examples of thermometers. And this
Have
temperature
you done?
scale is how well a particular thermometer can measure a certain value. Like I said, like the thermocouple, like we said earlier, if we started with, I
Okay.
say it measure a very high temperature compared to our clinical thermometer. The clinical thermometer, those one you find in the hospitals, right? So what that thermocouple can measure, that clinical thermometer cannot measure because it does not have that range. It does not have that numerical value to measure that or that design to measure that kind of temperature. So temperature, all these kinds of all these kinds of temperature you see, it depends on on what you want to measure. You now have,
Reluctance.
yes, temperature depends on the temperature they want to measure. That's why you assign different thermometer to different things.
Okay.
Like that thermocouple now, thermocouple cannot measure human temperature. Human temperature is too low. That one is to measure a very high temperature. That's why they use clinical thermometer to measure the temperature of humans. So where we are going to now is what we call temperature scale. Please, like I said, this area is very interesting. This is where most of your question will be based. And it doesn't mean they will not say question for what you have done so far.
Temperature scale.
Yes, temperature scale of thermometers. Temperature scale of thermometers. Okay. So a temperature, every thermometer has two reference scale or two reference points. So a thermometer
Every
has, yes, a thermometer, right? That a thermometer has two reference, reference temperatures, two reference temperatures or fixed points or fixed points. So let me explain this to you. Say thermometer have two reference temperature or fixed points. Let's use what we all know, which is the clinical thermometer or the liquid in glass thermometer. That's how it's also called because there's liquid. The thermometric substance is liquid. That's why you call it liquid in glass thermometer.
thermometer.
Yes. Now, before you use it, like I said, the thermometric substance will be at a certain level. After you use it, it will rise to another level, right?
Yeah.
Uh-huh. That's what we mean by fixed points. That's what we mean by fixed points. So the fixed point is the lowest point, and the other point is the highest point you can measure. So every temperature is designed in that manner. They have two reference temperature or fixed points. So what are these fixed points? They
Low,
call
begin,
them
and high.
uh, no, they call them lower fixed points.
Okay.
Lower fixed points, yes, lower fixed points. And two, the other one is called the upper fixed points. The upper fixed points. The lower fixed point and the upper fixed point. That's what they are called.
That's the scale of thermometer, right?
Yeah, the scale thermometer. Yeah, the lower. Yes, there are two scales. That you have the
Lower.
the lower or the upper fixed point. Are you done with that?
Yes.
Okay.
The
Okay, let's take the first
continue.
one. Let's understand the first one, which is the lower fixed point. Let's take the first one, the lower. Please pay attention to this thing we are doing. The lower fixed point. So the lower fixed point is defined is the temperature of pure melting ice at standard temperature. At standard temperature. At standard temperature. Sorry, at standard, not standard temperature, at standard pressure. At standard pressure of mercury. At standard pressure of mercury. So you look at the what they mentioned here. It says is the temperature of what? Pure melting ice. Yes. So the question is, at what temperature does ice melt? What's the temperature ice begin to melt? So when you put ice, when you remove ice, maybe you put pure water on the freezer and it becomes blocked. When you remove it, when you keep it on, remove it from the freezer, after some time, it begin to melt, right?
Yes.
And so at what temperature will it get to before it start melting? So the temperature of a melting ice is 0 degrees Celsius. So when temperature becomes 0, that is when the ice will start melting.
0
Okay?
degrees.
Yeah, 0 degrees. Ice melts at 0 degrees Celsius. So let's put that into account by saying ice melts at 0 degree Celsius. That is the temperature ice melts. So when you say the temperature of a pure melting ice, meaning that what's the temperature of pure melting ice now? Is 0.
0.
That temperature says 0, yes. Are you there?
Yes, sir.
Yes.
Okay, let's go to the upper fixed points now. The upper fixed point. Okay, so this is the temperature, is the temperature of steam, of pure boiling water, at standard pressure of mercury. So the other one, it says melting of ice. This one I say is what? Is boiling steam. Okay. So when you heat water, you see some smoke coming out of the kettle or the pot. What is that smoke called?
Away
When you
from
heat water, you see smoke coming out or from the mouth of the. That smoke is called steam. When water boil, it becomes the vapor becomes
Smoke
steam.
vapor. Okay.
I did hear you.
Smoke. What vapor? What is
steam,
different?
steam, steam.
No, that vapor you're saying generally is referred to as vapor, but what the actual name? The actual name is steam. Steam.
Steam,
Yes, it's steam.
steam.
It's steam. So at what temperature does water boil? Water boils at what temperature?
100,
Water boils, yes, at 100
100.
degrees Celsius. That's the temperature water boils. Then ice melt at 0 degrees Celsius. Are you there?
Yes.
Okay, so what I will do now, let's sketch a graph to illustrate these two. Let's sketch a scale, temperature. Let's sketch the scale now. So this scale is something like this.
This is the diagram.
Yes, this is the upper fixed point, upper fixed point. While here's the lower fixed point. So the upper fixed point, the temperature there is what? Is 100 degrees Celsius or 0 degree Celsius. Okay. Have you drawn it? Are you done with the
Yes.
diagram? Okay. So
Yes,
the
sir.
difference between these 2 points, the difference between them, we'll call it a fundamental interval. That's what it's called. The difference between the upper and the lower fixed point, referred to it as the fundamental interval.
Why
So
is
we're
it,
going to
sir?
define that. That is the definition of fundamental interval. So when you subtract the upper fixed point from the lower fixed point, what you have is a fundamental interval. It's a terminology in temperature. It's a terminology in temperature. So let's define it. Fundamental interval. Fundamental interval. So is the difference between the upper fixed point, and the lower fixed point, and the lower fixed point. It's called the fundamental interval. Okay. I've written that.
Yes.
Okay. So we are going to stop here. In our next class, we are going to do types of temperature scales. That's why we are going to do some calculations on it. But what you have to understand this concept: fundamental interval, upper fixed point, and the lower fixed point. It's very important. The types of thermometer. I believe you are going to see all those things in your first TME. But we have to treat some things first before you go to that. We're going to see a lot of questions we are going to do. We are going to do a lot of calculations in our next. How you convert from Celsius. We have three types of temperature scales. We have Celsius, we have Kelvin, and we have Fahrenheit. These are the three types of temperature scale that we have. We are going to discuss them and how each of them is different in terms of their mathematical relations. Okay, but before they need to read up this fundamental interval, upper phase point and lower phase point. It's very important. Hello?
Yes, we are with you, sir.
All right, so that's what you do for me before we finish another class. So thank you for your time.
Thank
all
you,
right.
sir.
All right, good night. All right.
Good night.